guys, today we are going to look at rational functions. So remember that word rational, root word ratio, we write them like fractions. So these are functions that are going to have variables in the denominators. So we're going to see what these will look like. And if you thought that polynomial functions got weird, remember when we were playing Simon Says? These ones are really strange. So we're going to look at just some characteristics of them today, some characteristics tomorrow, and overall we'll be using Desmos to graph these. We just want to know where some of the weirdness comes from. So if we're going to start out with graphing a rational function, we're going to start out with the most basic one I can come up with, and that is y equals 1 over x. So whenever we encounter a new function to graph that we have no idea what it's going to look like, our overall strategy is let's just plug in some numbers and find some points. Okay, so let's go. Well, I can't put a 0 in, can I? Because then we would have 1 over 0 and we would be dividing by 0, and we can't do that. So I can't put a 0 in, but I can put a 1 in. So if I put a 1 in for x, 1 over 1 is 1. If I put a 2 in for x, 1 over 2 is 1 over 2, that's a half. If I put a 3 in for x, 1 over 3 is 1 over 3, that's a third. If I put a 4 in for x, it's 1 over 4. So there's some values. Okay, so I want to extend this a little bit. Let's put some negatives in. If I put a negative 1 in, I would get 1 over negative 1, which would be negative 1. If I put a negative 2 in, I would get 1 over negative 2, which is a negative a half. If I put a negative 3 in, I would get negative a third. I think you're getting the idea there. Now what I want to do is actually put a fraction in. Okay, so I'm going to put in, for x, I'm going to put in 1/2. So let me write this function down again so you can see it since it moved up a little high. So if I'm taking this 1/2 and I'm putting it in right here for x, what that means is my y value, it's going to look complicated if I write it like this. 1 over 1/2, like that looks bad. So I'm going to take this divide sign and think about it as multiplying by the reciprocal. So that means I could rewrite it as 1 times 2 over 1. So I'm taking my fraction in that denominator and I'm flipping it over. So that would give me an output of 2. If I put in the fraction 1/3 and I do that process, I would get a 3. If I put in a 1/4 and I do that process, I would get a 4. Okay, so I'm going to graph these. So hopefully you have a little piece of graph paper left. So okay, so this is really hard to graph this on here by touch screen. Oh, this is not looking good. So I put a 2 in, I put a half in, I get 2 and 3. Okay, so it's gonna do a curve, something like that. And then the one on the negative side is going to be something like this. It's really weird looking. This is what a rational function does. In fact, let me go over here to Desmos and graph it for you nice so you can see what it looks like and not my terrible hand drawing. So y equals 1 over x. So there it is. So let's talk about this weirdness that you're seeing here. So this graph, it's like shooting up really high as the x value is getting close to 0. Now, do you remember that we said when I went to plug a 0 in for x, I said, oh, I can't do that because then I'd be dividing by 0 and we can't do that. So if you notice, this graph, the red curve here, avoids touching 0. Now it's getting closer. I can move up and zoom in, and it's getting close to 0. The x value is getting closer to 0, but it's not touching it. So it's, let me go back up to the normal view here, home screen. So we call that an asymptote. Okay, so we'll put that word in our notes here in a minute. And in this graph, we see both a vertical asymptote because there's the line or the curve is not touching the vertical line where x equals 0. See how it like shoots up on one side and nosedives down on the other? It's like, whoa, I cannot touch 0. Avoid it. Abort, abort. And it like, you know, does everything it can to avoid touching that line where x equals 0. And there's also a horizontal asymptote that you see here too. We're going to deal with those another day. Okay, so today we're just going to look at vertical asymptotes, where the line like avoids touching something by going up or by going down. And we'll also look at holes in a little bit too. So let me go back over to the notes page. So let's put this as one page here. So the word that I mentioned before was asymptote. And it is a line that the function's graph gets closer and closer to, but doesn't actually touch. But doesn't actually touch. Okay. And yeah, as I mentioned, there are multiple kinds. There are vertical asymptotes, horizontal asymptotes, and oblique asymptotes. But today we're just going to look at the vertical ones. Vertical means up and down. Okay. So we are going to be doing that today by looking at a page from your packets, which I hope you have these packets. It looks like this. And what you're going to do is graph these on Desmos. So let me pull that up so we can talk about this a little bit. So I have this first one graphed here. So this is the first card that you'll see on here. So I want you to pull up Desmos and graph it as well. And on the paper, the asymptote is marked for you as a dotted line. And you can see it on the graph that the red lines of the function graph are avoiding touching a dotted line in here. Okay, and there's a connection between that point and something about the denominators, okay, because something about we can't divide by 0, okay? So that's what you're going to be looking for. You're going to graph them, and then you're also going to factor them. So you'll factor these and see if you can notice a connection between where the asymptotes happen and where what the function has in its denominator. Okay, so focus on the denominators with those. There are some cards on here that have a whole, oh yeah, I was going to show you this, sorry, I almost got sidetracked. So this first one has a vertical asymptote at x equals -1/4. So I thought I would graph that line for you. The blue is x equals -1/4, and just show you that the red function is getting close to it, but it's not actually touching it. If I zoom out, keep going up, go up, 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 zoom out, it's not touching it yet. And I could keep doing this all day and it's not going to touch it. That's what an asymptote is. Okay, so let me return that to the home screen and turn those ones off. Okay, now this one is really weird looking. It's what your second graph is going to look like on here, so I'll let you do some exploring with that. There are 2 asymptotes that you see on that one, but the main one I want to get to is this third one. So this is this card here, and I graphed it, and this is certainly not what you were probably expecting to see. It just looks like a line, and that equation that you're looking at does not exactly look like y equals mx plus b. So this is really kind of weird. When you factor it, I think you're going to get a clue about things when you see similarities in the numerator in the denominator and think about what you can do with those. But the thing I want to point out on the graph is there's this little hole indicated. All right, there's this tiny little hole that they've drawn on the graph. But if you look at this, do you see a hole on Desmos? I don't. It doesn't look like there's a hole, but the hole on the paper looks like it's supposed to be at 1, 1. So let me come over here to where 1, 1 would be. Actually, the x value is 1. I don't know what the y value is. It's really kind of hard to get this to click right on the right spot here. There we go. Okay, so look at that ordered pair. See how it says 1, comma undefined? What that means is, oh, and if you look under my arrow, do you see how it's an empty hole right there? That means if you plug 1 in for x, something weird is going to happen. So think about what that weirdness could be with what we have talked about with fractions and dividing by 0. So there's a hole in this line. And the reason it doesn't show up on Desmos until you actually click on that point is because it can get close to it. So if I like zoom in here, it still looks fine, doesn't it? Like you just see a line. But then when I, oops, it moved on me. When I click on that point again, there it is, there's a hole. It doesn't show up as you're trying to zoom in because it gets really close, really close, but there's actually a hole there. Okay, so we want to look at why does that one have a hole instead of an asymptote? That's so weird. But when you look at the factors, and this time look at the factors in the numerator and denominator and see if you notice anything, and maybe that will help you see why there's a hole on that. So you're going to do that with all 6 of these problems today. And then I want you to see if you can figure out, make a hypothesis as to why something would have an asymptote or why it would have a hole. And then we'll come back. So that is everything for now. Bye.